In this video, we're going to be discussing the features and functions of the YSS1000 software that is used with the YS1000 line of controllers. First of all, we'll start off by launching the software. We'll then go into the YSS1000 configuration function. And we're going to start a new file here by clicking on the new icon. What you see here now is the system data window that pops up when you start a new file. And to get things started, you can either populate these drop-down windows with the data on the data label on top of the controller, or you can actually communicate with the controller and have it populate this area for you. So we'll do that. So we'll click on the Upload System Data tab, and you'll get a communication window that pops up. You'll need to specify which type of communication you're going to be using on the YS1700 controller. Program communication would be the front serial port. RS-45 communication is the rear serial port, the A31 option. And Ethernet communication would be the port in the back of the controller, which is the A34 option. So I'm using the front port, serial port, so I need to specify a COM port. We'll then click Connection, and you'll see the software will go online and begin to communicate with the controller. And as you see here, it's interrogated the controller and got its model code. So we can tell it to upload system data into the software. And it's actually populated now. It says I have Ethernet and the FM option. This enables the software to make use of the functions available on each individual controller. Next thing we're going to do, we're going to actually do some function block programming here just to kind of show you how that functions. So let's click on, make sure we're set up for program mode here. We're going to do the function block method, and you can call this whatever you'd like. For example, call it test. Go ahead and click OK. Next thing you're seeing on the screen here is basically just the folders of the program. System data is where we were. The parameter section where we have some data sheets, some file information that you can fill out for your records. Input-output single comments, where we can identify all the inputs into the controller. P parameter comments, which are user values, and K constants. This is a good area to make note of what each parameter is, to keep track of that for programming down the road. If somebody comes in behind you and is trying to actually see how you programmed your application. The next thing down the list is the parameter setting. And these are all the parameters that are actually accessible via the keys on the controller. So you can actually go up to the controller, push buttons, and access these same parameters. What we're going to do here is set up a simple two-loop control. So what we'll start off with is the config 2 menu. That's where we're going to set up our scaling for our inputs of our two loops. In this section, we have some parameters like the control operation direction, reverse direct, depending on what your application is. But we're going to move down to the scaling. Currently, this, depending on how the decimal point position is set here, will dictate our range. So since we have one pound sign to the right of the decimal here, this scaling is actually going to be 0.0 to 100.0. For this demonstration, I'm going to have a range of 0 to 500. So as I was saying, based on the decimal point position listed here, to get a 0 to 500.0 scale, I have to enter 5,000. And we're going to use GPM as the engineering units. And we're going to call this FIC 1023, for example. That'll be displayed on the top of the controller. The parameters down here that have the 2 after them are for loop 2. So down here we have the same kind of scaling available for that. Let's do a pressure loop for the second input. So again, the decimal point position has one number to the right of the decimal. I want to use a range of 0.0 to 200.0 psi. So let's put in 2,000 for the 100% scaling value. So again, that's going to give us 200.0 as our top end for this. For the engineering units, let's use PSI. And this is actually printed on the scale of the loop screen. And we'll call this PIC-1023 to keep in lines with the other tag we used. We can go up here to our PID 1 section under the tuning menu. That's where our starting set point is set. Let's put in a value of, say, 400. And I'm going to put in a starting value for the PIDs of 8 for the proportional band and 12 for the integral. And that's for our initial tuning on the controller. We'll go over that in a few minutes. I'm also going to go down here and set some alarm values on these. We have a process high alarm here. I'm going to set that to 375. And I have a process low alarm. I'm going to set that to 125. Okay. In our config 1 menu, there are some settings here for loop display, what we're actually going to see on the screen. By default, they're all turned on, and that's a lot of screens that you may or may not need. So what I'm going to do is go in here and turn some of those off. I actually have 3 different trend screens we could see. Don't need all of those. Okay, we've got that configured. We're also going to have use some of the discrete inputs and outputs on this controller. So down here we have a section for that. We can go in and tell it basically there are a total of 6 discretes. We can have 6 DIs, 6 DOs, or any combination of there. I want to use one DI, so I'm going to use DI1, and that's already configured as a DI, which is fine. I also want to have 2 DOs that we could connect to a horn, a light, or a buzzer, or something of that nature. So I actually need to configure those as DOs. Just click the drop-down window and choose DO. So those are set up. So basically we've got all of the parameters set for the controller that we need to make this dual loop control function. Next thing we need to do is move over to the function block programming. And just click the folder here. And we're going to be using dual loop. Click OK. And then you're presented with a blank screen. You still have your folders up here. This window shows you, you can go to the different pages of your program. The module window gives us access to all the function blocks in the controller or that are available to the controller. And down in the bottom window, or the fourth window, are all our registers. And we'll go through those in a second. First thing we need to do, we're going to set up 2 independent control loops. So what I've got here is we need to start off with the inputs to these loops. So we need to go into the register section, and under our process data area, process data, analog input outputs, we've got X's and Y's. X's are always going to be our inputs, and on this unit we have 5 analog inputs. The Y's are our outputs, and we have a total of 3 on this unit. So what I'm going to do, I'm going to use for the flow loop, I'm going to use X1 as the input. So if you left click that, drag it to the top, you'll see it appear there. I'll grab X2 while I'm here, stick that over here for loop 2. So now we have the inputs for our loop. Next thing we need to do is we need to go in here and grab the PID block, or what Yokogawa speak, we call it the basic block. There's BSC1, BSC2 for basic 1 and basic 2. That's actually under here the control function here. So if we left click on basic 1, drag it over to the white section, we can drop it in, and then to make X1 our process variable for this first loop, we just connect the 2. And all control loops are going to need some type of output, which is this. We need to connect that to a physical output. So we're going to use Y1, which is the first analog output. And again, we'll click that, drag it over to the bottom of your screen here, drop it, and then we can connect that to the output of our PID block, or basic block. We're going to duplicate this for the second control loop using BSC2. Connect the 2. We're going to use Y02 for our second output. Drop that down at the bottom, connect the 2. So now you have the bare minimum function block code to make 2 independent control loops function. We can add some other things to this as well. For example, if say we have 2 set points that we want to toggle between, we can do that using a switch block. One nice thing about the YSS1000 software, you can actually search these windows. So if you right click on, say, module and expand, and we're looking for the switch block, if you type in SW quickly, we do a search down that list and we actually come up with SW. So we're going to put that right here. And you see it has 2 inputs here and a switch or enable input here. So we're going to link in 2 of the P registers, which will hold our different set points that we want to switch between. And the P registers are down here under register. So we can click here and then just type in P0. And we will scroll down to P01. And similarly, like we did with the X inputs, we can drag these P registers to the top. Connect that to the first input. We'll take P02. We'll drag that to the second input. we need a trigger for this, so we're going to use one of the digital inputs that we assigned earlier. So I'm going to use the search method again and find one of the digital inputs. So we've got DI1 here, and that's going to be our trigger for this switch block. So when DI1 is open, we'll be using the set point in P01. When we close DI1, we're going to be using the set point in P02. Next, we need to write that particular set point to the set point register. So if we go back to our handy dandy register and expand and look for SV, which is the set value or set point. SV1 is for loop 1. Drag that to the bottom and connect that to the output of our switch block. Okay, continuing with the control loop here. For example, on the second loop, I may have a control output that normally we have a 4 to 20 milliamp output. Maybe I want to reverse that and have 20 milliamps to 4 milliamps. So 20 being your 0% output and 4 being your 100% output. What we need to use is basically a linearizer or a g of x function. So I can go into our modular block and find gx1. We'll take that, we'll drag it over, put it here after the output of the basic block, but before the input of the output block. And we can go ahead and connect those two. Connect the output back down to our analog output. So now we've got that. And one thing you may notice now, in the bottom left-hand corner of all these blocks, you'll have numbers. What those are order of execution numbers. So this block will be executed first. This output is second. Basic block 2 is third. The output is 4. And then we have this g of x, which is 7. So this means that the output actually gets written to before we do the g of x conversion, which could cause some problems down the line. So what we want to do is change the execution order. Since this block is directly after the or directly before the g of x block, we need to make them sequential. So let's make this one 3, which it already is. Change this one to 4. If you go up to the icons here, you can hover and it'll tell you what the icons are, but we're looking for the change execution order. This window pops up, and what we want to do is make GX1 executed before our our Y02. So just click it, left click, hold it, drag it, and drop it on top of Y2. And that'll put the GX above the output block, which will make the program run like it's supposed to. So now we see that that's changed. Okay, we've made some settings for P registers. We've used those. We've also used this G of X block. Now we need to go back into the parameter settings and actually set values for these. So let's do the P registers first. If you go into your parameter settings, you have your P scale. So we're using P1, which was 0 to 500. So again, we need to put in 5,000 here, since we have one number to the right of the decimal. And then For the P2, it was also going to be a scale of 0 to 5,000. Because this is remember, this is the set point for the first loop. We'll then go to the actual P register settings where we actually set the values. So we're going to use 400 for our first set point and 100 for our second set point. All right, the next thing we need to set is the G of X values. When you open up this G of X table, the default settings are you have your inputs and your outputs. So the inputs of the block, 0 to 100%, and then you have your outputs, which are 0 to 100%. So what comes in goes out. We want to reverse that. So the only thing we need to do is go down here to the outputs section, and basically on this you have a 0. We need to make that 100, or a 1.0 actually. And then we're going to count down from there. So we have 0.9, for 90%, 80, 70, and so on down the list until we get down to the bottom. And then finally with the last block is 0. So now if you look at this, I have 0% coming in. The output's actually going to be 100% out. Again, with the input of 10%, I'm actually going to have a 90% out, and so on down that list. So we can basically invert that output from 4 to 20 milliamps to 20 to 4 milliamps. Okay, now that we've got that done, we can go ahead and close that window, and we do want to save this. So again, I'll just call this test. And we're ready to actually dump this down into the controller. So if we close this window, it's going to ask us to save this portion of the file, which we did. We'll go up to communication, and what we're going to do is we're going to download all data. Downloads are always to the controller. Uploads are always from the controller to your PC. So let's go download all data. And you'll see that we're communicating here. When you download to the controller, you're going to have to actually stop the controller, and that'll hold the last output. So we'll click download all. And that's just a warning saying we're going to, are you sure that you want to download? So we do. This takes a little bit of time, not a whole lot, but a little slower than the Ethernet connection. So once you do that, you'll see the tag appears at the top of the screen, and the range has changed. Your set point should be set. This window that pops up is just asking you to check the load factor, which is this section here. It's just the load on the CPU, and they don't want you to get above, say, 80%. So we can just click OK there, put it in run mode. And with this program running, we're about 5%, which is very, very low. So now that we have our program into the controller, we can go actually look at what's happening inside the controller with the tuning function. So back up under communication, we can go down here to tuning. What we've got here is a nice little trend of the process. We do have a little bar graph here of our controller. Here's our set point. There's our current process variable and our output. We're currently in manual mode. This little M's lit up. As you can see, both of the set point and the output are down here. Yellow is our set point. So let's put the control in automatic. As you remember, we have a register table here, which displays our PID settings. In our initial setup, we set the proportional band to 8 and the integral to 12. So that should give us some fairly decent control. But let's go through here and look at that. Let's put control in automatic. And you'll see our output start swinging up, increasing. And the outputs or the process variable, our flow is responding. We're at 100% output right now, but you'll see the flow rate rising up, and we're starting to arc just slightly as we're getting closer to the set point. We're going to cut back on the output here shortly. There it goes. And we're going to ease on into the set point. We're not going to overshoot here. We're going to just rise up and stop at the set point. We're at about 395 right now with a set point of 400. $398. $399.2, 0.3, 0.4, and we're basically at a steady state here. The set point, the output, and the proportional integral and derivative, our PID settings, come default in this table down here. I've also come in and put in some other values. I put in our DI that we set, DI1, our two DOs. DO1 was the high alarm or limit, and DO2 was the low alarm or limit. P1 and P2 are our set points. We're currently remember the trigger for the set point change was the DI1. Since DI1 is open, we're at 400. If I were to close the DI, we would go to 100, and I'll do that in just a second here. I also have a listing for our high and low alarms. So we're at a steady state here. We're at 400 GPM actually, an output of 92%. And since we're right at set point, you're only seeing one line there, one color, yellow. Let's go ahead and switch set points by closing that DI contact. You'll see DI1 here changed to a 1. Immediately our set point dropped down to our preset of 100. Our output dropped to 0 briefly. As the flow rate's coming down, we're seeing our output starting to increase just a little bit to prevent it from overshooting or undershooting. So we're getting close to our set point there. This is a very useful tool if you want to monitor your process, kind of on a temporary basis. It also helpful if you want to try different PID settings, punch in, raise your proportional band a little bit or your integral. Okay, we're right about set point here. Next thing I'm going to show you is what we call our self-tune. or we can have the controller go out and basically tune itself, kind of learn about the dynamics of the process. To do that, it's pretty simple. Get your controller, your process in a somewhat of a stable state, get fairly close to the set point. Put the controller in manual. Then on the controller itself, you will actually go into the self-tuning menu, turn the STC parameter to AT startup, and you will put the controller back in automatic. And after a few seconds, what you're going to see is the output will bump 5%. That's the default setting. You can change that, make it higher or lower, but the output will bump 5%. The process will respond accordingly. The drop will go back to, or the controller will take the drop away, go back to the regular output setting, and you'll see it do some calculations for when it was tuning as to what PID settings it should use. So it comes up with its own. And right now you've seen that the output has dropped. That's our 5% bump. Since the process is lowered, the flow rate is going down. And here in a few more seconds, it's going to pop back up to its normal value the output is. The process variable, the flow, will come back up to the set point, and then the controller will wait a few seconds and then come up with its own PID settings, automatically setting them for you. So look at the proportional band is 8, the integral is 12. That's the ones that I've set, and the controller will automatically set those for us here. There's also a mode in the self-tune where you can have the controller just suggest settings. If you've got a process that you really don't want to bump like this, you can have it just look at the process and suggest settings. That's useful as well. Okay, looks like we're just about done with auto tune here, or self-tune. As you can see, the proportional band has changed slightly to 20.7, from 8 to 20.7, and the integral has changed from 12 to 13. Derivative hasn't changed because this is fairly fast reacting loop, so I wouldn't expect to have any derivative term. But that's the self-tune, so it's all ready to go. Control the process using these new PID settings. You don't have to do anything else. It's going to just go back and start controlling normally. So we're still in automatic here after the tune. If we were to open up the contact, we'll see this DI contact go from a 1 to a 0. And if you watch, you can either watch here for your set point, or the blue bar will change to 400, or you can see it change here as well. So let's open that. See our yellow line, our set point bumps up to 400. Our output immediately changes to try to raise that flow rate to that new set point. And our green bar down here is tracking that process variable change. And we're almost there. The settings we put in there seem to be just a little more conservative than the 8 and the 12, which will give us better control. You can actually save this trend in a CSV file or comma separated variable that can be opened up into an Excel spreadsheet and then converted to a graph there. In this, since we've got two loops, we could actually go look at the second loop as well. And the settings that we made here have been sent live down to the controller, but they aren't part of the configuration parameters that we've set. So if you want to make those permanent in the configuration, I recommend doing an upload from the controller. And the software will kind of remind you that any changes that you've made are not part of the program yet, so you actually do need to save them or upload. So let's go ahead and do that. If we close this window, we have an opportunity to save the trend data. We can say no. And it's telling us now that if we've written to these register, perform an upload from the controller. So now we're back to that blank screen again. Let's go ahead and upload. So we'll go back to communication. We'll do upload all data. And this is just saying the program that is currently in the software is going to be deleted, which is not a problem because it's already been downloaded to the controller. So we can go ahead and click yes. Well, that'll just save the data there. So we can click no. So we're communicating and we want to click this long bar, upload all data. Again, this is a little slower than the Ethernet connection, but not too bad. Okay, we're complete. So now we can go here and save this. And like I always say, you should save early and often. You don't want to be working on a program and not save your changes and have to go back and reinvent the wheel. So we'll save that file. We just want to overwrite it. That's fine. One last little quick thing over on this introduction. We'll be coming out with more videos with some more in-depth training on these function blocks as time permits. But we can actually go in and pull up a register monitor as well. And that may look familiar because that's the same window that we saw minus the trend graph at the top. So if you're just looking at the raw data values, we can see that here. And one last thing I neglected to show you on this was the module monitor. Under communication, if you click that, that actually brings up the inputs and outputs from each individual block here. So we've got the DI coming in as a 0, and we'll be using the 400, and in the switch block it basically converts it to 0 to 100%. So this is 80% of 500. If we were to close that, you'll see the contact change at the top. This is our DI, changes to a 1. And we'll switch to the 100 GPM set point, which is 2%, or I'm sorry, 20% of the 500 range of that transmitter. And if we open up, we'll see that contact change again, and we'll go back to the 80% set point. But so for this loop here, I've got 46, 48% because we're rising up back up to our 400 degrees. And this is our output. It's going for almost 100%. We're getting closer to our set point, so we're backing off on that. This particular tool is invaluable when you're programming. If you've got some problem with your logic and you're not sure what's going on, where your problem is, this is the portion of the software to go and help you troubleshoot where your error might be. As I said earlier, we will become coming up with more videos on the YSS1000 software, a little more detail on the function blocks to help you with your specific applications. I wanted to thank you for viewing the video. If you have any questions, go to our website. We've got all of the information on the controllers and the software there. And again, thanks for listening.